Hello everyone, I am David Milan and welcome to my channel FactUSA Nova. Let's discover an amazing fact in every day.
Ultimate planetary paradox. We're looking at a world that honestly, by all logic, should be Earth's perfect twin. I mean, it's right next door in the solar system, it's made of the exact same materials, and it sits comfortably right inside our sun's habitable zone. But instead of an inviting, tropical paradise, it's actually a deadly, crushing hellscape. So how did a planet with so much potential turn into the most hostile environment imaginable?
When you actually run the numbers, it's wild how similar we are. Venus has a diameter of about 12,100 kilometers. That's like 95% the size of Earth. And the gravity? Nearly identical. To put that into perspective, if you got a 40-kilogram kid standing here on Earth, they'd weigh about 36 kilograms on Venus. So physically speaking, we're basically looking at twins. But then, you look at the temperature. A perfectly comfortable 15 degrees Celsius on average for Earth, compared to a blistering, lead-melting 465 degrees Celsius on Venus.
So here is the million-dollar question. If they started out so similar, what went catastrophically wrong? How did it turn into the evil twin of our solar system? Scientists actually think that billions of years ago, Venus might have had liquid oceans and an atmosphere a lot like our own. But something happened. Something triggered a massive chain reaction that completely wiped out any chance of life as we know it.
Section 1. The hottest planet paradox. A cosmic fair test.
Okay, think about this like a cosmic fair test. If you ask anyone which planet is the hottest, logic says it should be Mercury, right? It's the closest to the sun. But the data tells a completely different story. Mercury has these wild temperature swings, up to 430 degrees Celsius during the day, plummeting down to a freezing negative 180 degrees at night, all because it doesn't have an atmosphere to hold on to that heat. Venus, on the other hand, sits further away, yet it actually beats out Mercury as the hottest planet in the solar system. It stays at a constant 465 degrees Celsius. Day, night, equator to pole, it barely changes at all.
What we're seeing here is the extreme consequence of a runaway greenhouse effect. See, Venus is hotter than Mercury because it's completely fueled by a thick atmosphere that is roughly 96.5% carbon dioxide. This massive layer of CO2 acts like an inescapable heat blanket, wrapping the entire planet. Sunlight streams in, but the heat absolutely cannot radiate back out into space. Whatever oceans Venus once had literally boiled away. That fed even more water vapor into the atmosphere, which just totally accelerated this vicious, unstoppable warming cycle.
Section 2. A very bizarre sense of time, when a day outlasts a year. 243. That is the number of Earth days it takes for Venus to complete just one single rotation on its own axis. It is an agonizingly slow spin. In fact, it is the longest rotational period of any planet in our entire solar system.
And that leads us to an absolute mindbender. Because Venus orbits the Sun relatively quickly, taking just 225 Earth days to complete its year, its day is actually longer than its year. Think about that. By the time Venus has spun around its axis just once, it's already celebrated a new year. Crazy, right?
Even stranger, it spins backwards. We call this retrograde rotation. If you were miraculously standing on the surface, you'd actually see the sun rise in the west and set in the east. Scientists suspect this backward spin might be the result of a massive cosmic collision really early in the solar system's history that literally knocked the planet into reverse. And because of how this slow backward spin interacts with its orbit, a solar day, the time from one sunrise to the next, takes 117 Earth days. You would literally only see 2 sunrises in an entire Venusian year.
Moving on to Section 3. Acid clouds in superrotation. The 300-kilometer-per-hour winds.
You know, when you look up at the night sky from Earth, Venus is often the brightest, most beautiful object after the moon. We frequently call it the morning or evening star. But those beautiful, bright clouds reflecting 70% of the sunlight back into space, they aren't made of water vapor. No, they are composed of highly toxic sulfuric acid. They form this incredibly thick layer between 45 and 70 kilometers above the surface, completely hiding the planetary crust from our view.
And this setup creates a wild phenomenon known as superrotation. While the solid planet itself spins at an absolute crawl, the atmosphere is just racing. The upper atmosphere whips around the planet at staggering speeds of 100 meters per second. That's roughly 300 kilometers per hour. This means the atmosphere is rotating up to 60 times faster than the solid globe underneath it. It circles the entire planet every 4 to 5 Earth days. It's just a massive swirling engine of momentum that planetary scientists are honestly still trying to fully model and understand today.
Section 4. Surviving the Venusian Surface. The Soviet Venera Missions.
This is a thrilling, but ultimately totally doomed survival story. Throughout the 1960s, 70s, and 80s, the Soviet Union sent a series of probes, the Venera missions, to pierce those clouds. In 1970, Venera 7 actually achieved the very first soft landing on another planet. It plunged through the sulfuric acid clouds, sank through an atmosphere that was getting thicker by the second, and finally touched down. But despite the absolute monumental effort it took to get there, it managed to transmit data from the surface for a mere 23 minutes before it succumbed to the crushing pressure and melting heat. Its signal was lost forever. To this day, no spacecraft has ever survived there for more than a couple of hours.
To really wrap your head around what that crushing surface pressure actually feels like, imagine being nearly a kilometer underwater in our own oceans. The atmospheric pressure at the Venusian surface is 92 times greater than Earth's at sea level. Because the carbon dioxide is just so incredibly dense, the winds at the surface actually slow right down to just a few kilometers per hour. But as we understand it, the air is so thick it acts way more like a deep ocean current, easily dragging small rocks and dust across those scorched volcanic plains.
Section 5. What Venus Teaches Earth. A Warning from the Future.
Despite all of this overwhelming hostility, humanity is actually heading back. We have massive gaps in our knowledge, and Venus is finally back on the exploration agenda. NASA's Da Vinci mission and the European Space Agency's Envision mission are both slated to launch in the early 2030s to map the surface, study the chemistry, and literally drop probes directly into that chaotic atmosphere. And here's why these missions matter so much. Venus isn't just a weird anomaly. It's a vital, cautionary laboratory for Earth's own climate literacy. By figuring out exactly how a planet so similar to ours lost its oceans and suffered a runaway greenhouse effect, we gain absolutely invaluable insights into the delicate balance of our own atmosphere and long-term sustainability.
Which leaves us with this final thought for today's explainer. We've seen the 465-degree heat, the toxic acid clouds, and that bone-crushing pressure. So will future technology and dedicated terraforming efforts ever let us tame our evil twin? Could humans one day stand on that surface and watch the sun rise in the west? Or is Venus simply a stark permanent warning floating right next door? A terrifying glimpse of what happens when a climate system goes completely over the edge. It's a profound mystery. And as those new probes arrive in the 2030s, we might just get some real answers. Thank you so much for joining me, and keep your eyes on the skies.